Hello class, today's lesson is going to discuss about threads. By the end of this lesson, every student will be able to explain what thread is, differentiate thread with process, explain types of threads, their advantages as well as the disadvantages. Hope you are going to enjoy the lesson. Let's begin by defining what is a thread. A thread is the smallest unity of processing that can be performed in an operating system. So the thread is the smallest unity being performed in the operating system. So last time we discussed what is a process. We saw that a process is a program being executed. So there may be time where a process is very big. So when the process is very big, it's possible that the operating system can divide into different parts of the program so that the execution can be effective. So that's the time we call them threads. For example, if you open your browser, let's take an example of Google Chrome. Launching Google Chrome itself, the Google Chrome, it's a process. But there may be time you need to browse many different pages or many different websites, and you open different tabs. So those tabs, each tab is considered as a single process, yet it's not a process. The process itself is Google Chrome. So by opening a new tab, so you are creating a thread. You open another tab, you create a new thread. So, and the process being known by the operating system is Google Chrome, but Google Chrome itself has created some other sub-processes that we call threads. But in a traditional operating system, that's not possible. So the process occupies the entire memory and it executes at once. While in the modern operating systems, so the process can be divided into sub-processes that we call threads to facilitate parallelism execution, which means many activities, many programs being executed at the same time in a single memory location. Each thread belongs to exactly one process, and no thread can exist outside of the process. So this is understandable. The thread is created by the process. So it's the process to create the thread. So which means a thread cannot exist outside of the memory. Outside of the process. So the threads provide a suitable foundation for parallel execution of applications on a shared memory multiprocessors. So the thread favorises or helps the programs to be, or the applications to execute different parts of the program at the same time. For example, while using a calculator, while you were performing a binary number on a given number, on the same number you can operate hexadecimal and so on at the same time, at once, without launching a new process. We can the difference between a process and a thread is simply that the process is the one to create threads. So a thread has no similarities to a process. threads also have life cycle. Shared processor. They share the processor and execute sequentially within a process. So you can't compare a process with a thread, since a thread exists because of the process. But there are some differences in the table below. Process cannot share the same memory, while the threads can share the same memory and the same file. So which means in the same memory, the two processes cannot belong in the same memory at the same time. So each process has to execute, then leave the memory, another process comes, and so on. So we'll discuss this later in process scheduling. Process creation is time consuming. It takes a long time to create a process, while it takes little time to create a thread. A process execution is very slow, while the thread execution is very fast. It takes more time to terminate a process, while it takes less time to terminate a thread. It takes more time to switch between two processes, while it takes less time to switch between two threads. Communication between processes is difficult, while communication between threads is easy and efficient. A process is a heavyweight, while a thread is a lightweight and requires fewer resources. Some advantages of threads. Threads minimize the context switching time. So moving from one thread to another, it takes less time. Use of threads provide concurrency within a process, which means when you develop an application and you implement threads usage, so the different parts of your application can execute at the same time. Efficient communication. There is an efficient communication between threads. It is more economical to create and context switch threads. So when developing an application using threads, so it consumes less time. Threads allows utilization of multiprocessor architecture to a greater scale and efficient. So using the threads helps the processor to perform well and very fast. We have two types of threads. We have user-level thread, which is the user-managed thread, and we have the kernel-level thread, which is an operating system-managed thread, which acts on kernel, which is an operating system core. So, talking a little bit about operating system main part. So we know that an operating system is made of two main parts. We have a shell part and we have kernel part. So the shell part is the outer part of the operating system, which is responsible of interacting with the operating system. For example, we have peripherals like a keyboard, like a mouse. So these are the peripherals helps the user to interact with the keyboard. So they exist in the shell space. Then you have the kernel, which is responsible for managing and controlling computer resources such as processor, main memory, storage, input device, and so on. So now you have connected your keyboard. You type using your keyboard. How the computer memory or how the computer processor will know that you have connected the keyboard? How will it know that you have typed something so that it can process it? So after shell interacting with the keyboard. Also, the shell will send the instructions or the resources to the shell, which is the overall manager of the computer resources. So the kernel is the heart. It's considered as the heart of the system. So in the user level thread, the thread management kernel is not aware of the existence of the thread. When the program is executing in the user level thread, so the kernel will not aware of the thread being created. So the threads are being created by the application itself, and they are terminated by the application itself without the invocation of the kernel. So the thread library contains code for creating and destroying threads. So the programmer writes the program so that the program itself will create a new thread. When the new thread is not in use, it can be destroyed. For example, in Google Chrome, it's not the operating system to terminate the new tab you have created. Simply, it's Google Chrome itself. So the application starts with a single thread. When you launch a program in a user level, it's only single thread, so that you can create multiple threads on your own. In Google Chrome, you open the Google Chrome and then it opens with one tab. If you need more, you click on add create new tab, and so on and so on. When threads are managed in the user space, each process must have its own thread table, and the thread table consists of the information on the program, counter, and the registers. So in this case, when the program is executing in the user level, so it's simply the program, the application to know the existence of the thread, the register it's occupying, and how many threads have been created by that application. So the operating system will not aware about all those threads. What the operating system will know, it's simply the process which have been created. Then the process will create threads on its own. Here we have the example where we have, these are the threads. This is thread 1, thread 2, thread 3, which have been created by the process P1. So what the kernel will know, it's only this P1. But what is happening inside the P1 is known by the application, the process P1 only. So the kernel will not know what is happening in P1. So in the user level is used to make threads cheap and fast. They need to be implemented at user level. So basically, it's the programmer who will decide how he or she wants to interact with the operating system, or if the application created will not interact with the operating system. But there may be a case where the application require the kernel to take part. So in that case, we use what we call system call. When the application, for example, the application requires to access the camera, and the camera is a device resource. So the device resources are managed by the kernel. So in that case, when the application needs to access the camera, first it will ask permission to access that camera. while accessing the camera, there will be the kernel will be invoked, and in that case, the application will launch or will send what we call system call, so that the kernel or the operating system can provide resources to the application to be used. So advantages of the user level. So the advantages are: thread switching does not require kernel mode privileges. User level thread can run on any operating system. Scheduling can be application specific in the user level threads, and the user level threads are faster to create and manage. So here those are some advantages of user level threads. Then talking about disadvantages. So the disadvantages will happen. One of the disadvantages is when the user level execute a system call. So it means when it requires some usage of device resources. So not only that a thread is blocked, but all the threads within the process are going to be blocked. So when there is a system call, all processes, all threads which have been created will stop executing. So then the system call will happen. Then when the system call is done, now the threads will be unblocked. So multi-threaded application using user level threads cannot take advantage of multi-processor, since OS is unaware of the presence of threads. So when you think you are writing a program which will require system call, so the application should be written to run at kernel level, not at the user space. So the kernel level, these are the threads that are managed by the operating system. So all in kernel level, all management are taking place at the operating system level. So there is no thread time table in each process, as the case of the user level. So it's the operating system. In the operating system, there will be the table including program counter and register, not as well as at the user level. So in the image here, the image here shows the difference. So as you can see here, we have, this is a process. Within the process we have threads. So the kernel will not what the kernel knows, it's the process, not the threads. While at a kernel level, the process are created. This is process 1, process 2, and the threads are also known at the kernel level. Here, this is the table for threads. This is the table for the process. So the kernel level will be the one to manage everything. So here we have the difference between the user and kernel. So you can go through, and we have advantages, disadvantages of both kernel and user level and kernel level. So this is the end of the lesson. So if you have any question, please feel free to text me. Thank you.